Welcome. In this video I'm going to show you how you can perform a Power Divergence test using Python and my stikpetP library. I have a separate video on if you don't want to use my library, if you want to use somebody else's their library, or no libraries at all. But in this video I'll simply use my own. I'm using Python version 3.818 and the focus of this video is how to perform the test, not so much if you should, because there are quite a lot of different tests that you could also use. Now, this power divergence is actually a set of tests because you can specify a so-called lambda value, and depending on that, the results will be different. There are a few that are, for example, if you use 1, it's the Pearson chi-square test. If you use 0, it's the G test. And for example, quite popular is the Cressie-Read, where it's set to 2/3. There are some conditions about minimum expected counts. And there are also some corrections that could be used. To show you how this can work, I'll first load in some example data, so I'll import pandas and then use it to read CSV to load some data. It's from the General Social Survey from 2012, adjusted for some example purposes. Now I don't need all the data, I just need one nominal field, so I'm going to be using mar1, which is marital status. And to give you a quick impression, let's do a values count, and you can see all the different categories. So for example, 79 people indicated to be separated. For an independence test, we need a second field, so I'm going to be using gender for this. And to get a quick impression now, I can use the cross table, and apparently there were only male and female options in 2012. Now my library is available not directly by using just pip install, but actually by using a link to my GitHub account and pip install. So if you use this, it should import, once installed, it should then import. The function, depending on if you use the goodness of fit test or the independence test, has a few parameters. So for the goodness of fit test, it actually needs just one factor. With pandas data series and an optional one, which is then for the independence test. For the goodness of fit, that one's not needed. You can use the expected counts for the goodness of fit test, where you can select what the expected counts should be. Of course, the lambda needs to be specified. By default, it's the Cressie-Read version. You can either fill out a value or one of these terms. Of course, you can also specify which correction you want to use, and that's about it. You can simply do a question mark with ps dot and then the name of the function if you want to see some more information. And in this case, if I run it, I only need to feed it the field, and it gives me the sample size, the number of categories, the test statistic, the chi-square value if I'm not mistaken, the degrees of freedom, which is the samples number of categories minus 1, the p-value, the significance level in SPSS, the minimum expected count, the percentage of cells that was below 5, and the test that was actually used. Now in this case the p-value is below 0.05 because this e minus 256 means that we need to divide this 8.79 by 10 to the power of 256, which means it's going to be 0 point and then a lot of zeros. So it's below the usual threshold of 0.05. We would then say it's significant. We would reject the null hypothesis and claim that in the population, most likely not each category will have the same count. You can also do it for a test of independence. So then I need to feed it both fields and I get similar results. The total sample size, the number of rows, that's the number of categories in the first field, the number of categories in the second, the test statistic, the degrees of freedom, which is the number of rows minus 1 times the number of columns minus 1, so 4 times 1 equals 4. Again, a p-value, the minimum expected count, the proportion of expected counts below 5, and the Cressie-Read, the test that was actually used. Again, here it's below 0.05, the usual threshold, so the probability of getting a 17.1 in a sample if in the population there's no association between these two fields is extremely low. Therefore, we would reject the null hypothesis and say that there is an association between these two fields. All right, I hope this was helpful, and thank you for watching.